Okay, Ohm's law makes us understand the relationship between a voltage source, a resistor, and the current between them. So let me give you a quick example. If you look at this diagram right now, if I turn on the circuit, you see there's a current flowing in the circuit right now, and it tells us that there's a 20 milliamp current when a 20 volt is connected to a 1 kilo ohms resistor. This is just basic Ohm's law. Now, this relationship can vary depending on other physical factors, but where other physical factors are kept constant, Ohm's law will stand. So let's get to the calculations of that right now. Okay, this is the typical example of the circuit we just saw just now. Now it says that the voltage source is 20 volts, the resistance is 1 kilo ohm resistance. So Ohm's law says that V is equals to IR. So we have here V, it's equals to IR, is equals to IR, where I stands for where R stands for the resistance and I stands for the current in the circuit. So when V is 20 volts, we have here that V is 20 volts equals to I unknown I times the resistance 1000 ohms. So we make the I the subject of formula. We have 20 over 1000 equals to the I. So divide. So we have the current is equals to 0.02 amp. So we see now that the current is 0.02 amp, and this is also equal to 220 milliamp. So this is a simple understanding of Ohm's law. Whenever other constants are kept, whenever other factors are kept constant, you have V is always equals to IR. So let's see other examples of Ohm's law now. Okay, this is another example of the same ideology of Ohm's law. So now there's a 20 volt source and we have a 2 kilo ohm resistor and a 3 kilo ohm resistor. So let's find the current flowing in the circuit right now. So we say Ohm's law says V equals to IR, and the resistors are in series, so we have 20 equals to the current flowing in the circuit times 2 plus 3, total resistance in the circuit. So we have 20 equals to 5I. So we make I the subject formula. We have 20 over 5 equals to I, making I equals to 4 amps. 4 amps. So this is the answer to I. Let's check if we are correct. Let's build the circuit in every circuit. Let's see if we are correct. So this is the same circuit we just calculated, where we had a 20 volt source and a 2 ohm resistor with a 3 ohm resistor. If you turn on the circuit right now, you can see that the current in the circuit is exactly 4 amps of current. This is when you are trying to search for the current in the circuit using Ohm's law. This is exactly what you do. What if we are given an example and we are asked to find the voltage or the resistance in the circuit. What then happens? Let's take an example. Okay, this is it. We are asked to find voltage in this example. We have current equals to 2 amps, resistance equals to 5 ohms. So what's the voltage? Now remember, Ohm's law says V is equals to IR. V is equals to IR. So the voltage is unknown. We want to look for the current. So voltage is simply the current 2 amps times the resistance 5 ohms. That's equals to 10 volts. It's as simple as that. Whenever you see the resistance and the current given, you can search for the voltage. Whenever you see the voltage and the resistance given, sorry about that, whenever you see the voltage and the resistance given, you can search for the current, vice versa. So that means, that said, current is equals to voltage over R, and resistance is equals to voltage over I. This is Ohm's law. This is Ohm's law. So whenever how the question comes and it's Ohm's law, you can use these formulas to solve. Thank you so much.